talking about number of solutions. So the solution to an equation is the value of the variable, right? We've been figuring out the solution when we find what the variable equals, and that makes the equation true. So some equations have one solution. The ones we've been solving have one solution, while some equations have no solution. So when this occurs, no value will make the equations true. So when we go through the process and we go to solve our process, it's going to kind of get rid of our variables, and we're going to have one number equals a different number, which is not true. So for example, if we were solving this, we would be taking 3x from both sides, but once we did that, we would be left with 4 equals 0. Well, 4 does not equal 0. So that's how we're going to come up with no solution. So we're still going to be following the same process, but some of these equations are going to be a little bit special in that they're going to come up with one number equals another number, which isn't true, right? So anytime we have a statement that is not true, there is going to be no solution. The ones we have been solving, we get to the point where x equals one number, right? This is what we are used to, but we're going to see a couple special equations where we end up with a number equals a different number, or we end up with one number equals that number. So if it's a true statement, then x could be anything. We could put any number in for x and it would make this statement true. So that's when we end up with infinitely many solutions. All right, so we are going to look at some examples of that. We're going to practice with that, and then we're going to review everything we've learned for our quiz on Friday. So when we go to solve, we're still solving the same way. In order to determine whether an equation has one, no, or infinitely many solutions, we still have to solve the equation just as we were, right? So first thing you should notice is that there are parentheses. This is page 160 if you're lost already. We still, to get rid of our parentheses, we have to distribute. Remember, that means whatever is touching our parentheses has to be multiplied by everything inside our parentheses. So we're going to say 6 times x, and we're going to say 6 times negative 3. They put our negative there for us, so I just have to write the 18. Then they brought the 10 down. Now that wasn't in the parentheses, but it needs to be included. We're just not multiplying anything by it. Then we have to distribute this 2 through. 2 times 3x is also 6x, and 2 times negative 4 is 8. And they have the negative there for us. So now we can combine like terms. There are 2 constants on the left that we can combine. We have negative 18 plus 10. So that equals negative 8. When we start to solve this by getting rid of our variables from one side or the other, and we subtract negative 6x, we end up with negative 8 equals negative 8. That's true. When our statement is true, I don't know what they want there. That's really weird. The equation, when it's true, it means we have infinitely many solutions, because x could be anything. We could put 500 in for x. We would still end up with negative 8 equals negative 8. The equation negative 8 equals negative 8 is, I don't know what they want there, always true, because any value can be substituted to make the equations true. So the equation has infinitely many solutions. So we can replace x with any value to verify that any solution will work. We could put in a 4 here. 4 here. So this is 4 minus 3, so 6 plus 10 is 16. Here we end up with 12 minus 4 is 8. 8 times 2 is 16. So that still makes it equal. Which equation has an infinite number of solutions? So in order to figure this out, we would start having to solve these, right? So we would distribute this 2, we would end up with 6c minus 12 minus 2c equals 4c plus 4. If we just simplified this one step, we see we have 4c minus 12 equals 4c plus 4. What's going to happen when we take 4 c's from both sides? Will it make this statement true or false? Does negative 12 equal 4? It does not. So this is no solution. So we know it's not number 2, our letter A. If we distribute this 3 through, we have 6p minus 3 equals 2p plus 20 plus 1. This one should give us one solution, because if we take 2p away from here, we're not getting rid of our variable term. We still have 4p minus 3 equals 21. We can still solve this. So it can't be letter B. We're looking for something where our variable term goes away, but leaves us with the same number equals the same number. So this has one solution. Part C, if we're putting 8x through, we have 8x minus 72 equals 12x minus 72 minus 4x. So when we combine these on the left, we end up with 8x minus 72. So do you see here where we're going to end up with negative 72 equals negative 72? Because if we get rid of 8x from both sides, we're left with a number equals that number. Since this is true, this has infinite solutions. So we can say C. We don't have to check D. Unless it asks us which equations, which would imply there were more than one, right? So does it take some work? Yes, you still have to solve equations to figure it out. So this gives us an example of infinitely many solutions. This one is giving us an example with no solutions, which means we're looking for a number equal to a different number, right? We're looking for a statement that's not true. So if we solve this as usual, it's good practice, right? 8 times 4, 8 times negative 2. Don't forget your x. Transfer your 12. 4 times negative 5 is 20x. Combine like terms, so these stayed the same. Negative 20 plus 4 is negative 16. Then look what happens. When we add 16 to both sides, 16x that is, we end up bringing down this 32. And since 32, this is not true, because no values can be substituted to make the equation true. So the equation has no solution. Now we have to work through some other of these to find one that doesn't. We had an example down here of one that doesn't, right? When a number equals another different number. So if I put through this 5, I have 5b plus 15 minus 2b equals 2b plus 3. Notice when we combine these, we're going to end up with 3b plus 15 equals 2b plus 3. When we have something that's infinite, has many solutions, they always have the same number of b's on both sides. They would cancel each other out. In this case, it doesn't. So this only has one solution. For part B, so we know it's not A. We're looking for something with no solution this time. If we put 4 through here, we have 4d minus 12 plus 5 equals 3d plus 6 minus 7. And again, we don't have the same number of variables on each side, so they're not going to end up canceling each other out. So this should only have one. Part C, we have 3x plus 15 is equal to 5x plus 15 minus 2x. So at first, this one might look like we're having one solution, but once we combine our like terms, we do have the same number of variables on each side. So this tells us that either this is going to be no solution or infinite solution, because we're going to end up getting rid of our variable term completely because they match, right? Whatever, if we do the same thing, we could get rid of them. But what happens? Is this infinite or no? When our statement is true, it is what? When our statement is true, it is infinitely many solutions. So this is true, right? 15 does equal 15. So this can't be no solution because it's any solution would work. I think you're right. So let's just double check. Negative 10y plus 18 is equal to negative 15y plus 21 plus 5y. So when these combine, we're going to have matching variable terms on each side. But once we get rid of those, do our constants match? Does 18 equal 21? Our constants do not match, right? 18 does not equal 21. So this is no solution. Do you see how you have to go about and think through them? If you can't think through them, you would have to go through and solve them so you get to this point or this point to check. Okay? So that is infinite no solution. It is possible to determine the number of solutions, this is page 162, to an equation without actually solving it. So this is going to give us some tips on how to do it a little bit more quickly. The number of solutions to an equation can be found after each side has been simplified. And that's kind of what we were doing in our last one. We were simplifying it so we can see. It says complete the table to indicate whether the coefficients and constants are the same or different. When it has no solution, the coefficients of our variable term are the same. How about our constants? Are they the same or different? They're different, right? 3 is not 1, so we're going to call these different. So once we have a simplified equation, we can look at it, right? These two would cancel out, our 6x's would cancel out, and we would have 3 does not equal 1, which would tell us there's no solution. There's no way 3 can equal 1. Now, when we have one solution, our coefficients are always different on each side. but our constants could be different or the same. If we're trying to see if something is infinite solutions, our coefficients are again the same, right? Our variable terms look the same on both sides. Once they're simplified, right? It's important that they're simplified first. And our constants are the same. So if you're struggling on the quiz, trying to figure out if it has one, none, or infinite, you could look at this table and evaluate your equation. Are my coefficients the same? Are they different or the same, right? So in order to create equations with infinitely many solutions, that means we want our variable terms to be the same. Our coefficients need to be the same for infinitely many solutions, and our constants have to be the same. So what is the coefficient of this variable term once simplified? What's 6 minus 1? So this ends up being 5x plus 2x is a total of 7x. So I want that to be the same on the right. So what would I put here? A 7. Yep. So they are just showing that here. This becomes a 7x. Now, what do I want my constant to be? If it's infinitely many solutions, I want my constant to be the same. So what's my constant going to be over here? The same. What is it on the left? 4. So we want this to be 4. So 6x minus x plus 4 plus 2x is equal to 7x plus 4 is the equation with infinitely many solutions. So try and complete this one. The first thing you're going to want to do is simplify the left because we're trying to figure out what our simplified coefficient would be. So simplify this, right? Distribute -2 through here. Combine like terms. Going to give you a minute to try that. Hopefully this is becoming automatic and you're not just staring at your paper and wondering what to do next. We've practiced these a lot. -2 times x. -2 times 5. We're trying to figure out, since we want our coefficient to be the same, we're trying to figure out what this makes our coefficient once it's simplified. So 4x minus 2x is 2x. So simplified, that's what we want this to be. We want this to be 2, and we want our constant to be -10. Because infinitely many solutions means they are both the same, right? It would end up being -10 equals -10. So we're going to think kind of backwards. We still, if we're creating equations with no solution, we still want our coefficients to be the same, but our constants can be different. So the same process, we have to simplify these first. So 3 times 2x is 6x, and 3 times 4 is 12. So now 6x minus x is 5x. So in simplified form, we want both sides of our coefficients to be the same. So what do I want my coefficient to be on the right side? The same. So what would I put in that box? 5 right here. And then we could pick any number as long as we did not pick 12. right? You could pick 11, 10, 7, 248. It does not matter. As long as it doesn't equal 12, it would have no solution because it would have no solution since they have the same coefficient and different constants, okay? So now, try this check here on 163. You're just going to simplify to figure out what your coefficient should be, and then pick a different constant so that it would have no solutions. You're trying to make your statement not true. This shouldn't take too long. If you're simplifying, you're combining like terms, so you can combine all your variable terms. -3 plus 8 is 5. 5 minus 1 is 4. So this becomes 4x minus 6. Since it has no solution, we want the coefficients to be the same. So here's your coefficient. Remember, your coefficient is the number in front of the x. So what did we want this to be? We want it to match. You could pick any number except for 6 to put in here. It does not matter what number. You could pick 1, 2, 3, 4, 5. You cannot pick 6. You could pick 7, 8, 9, 10, 11, 12, any number. 999. It does not matter as long as it's not the same constant on the left. Okay? That makes no solution. All right, so we have some practice. We're going to jump to page 167. You're going to determine whether the equation has one solution, no solution, or infinitely many solutions for the first few. Then you're going to simplify the left side of the next ones to try and make an equation that has either infinitely for 5 and 6 or no solution for 7 and 8. Okay? So try these out. Don't get freaked out by the 1/3. Remember that literally means divide by 3. So 12 divided by 3, 9 divided by 3 when you're distributing. All right, so you got some time to work through those. And we'll practice more tomorrow.